Hello, beta. Good afternoon, everyone. So, this is going to be the last session in mathematics, and I'm going to take the last two topics for today. That is going to be LPP and difference equation. And tomorrow, I am expecting all of you will go ahead and give a full syllabus maths test. And I will be going ahead and I will be looking into the results and I will be seeing how you have performed. The questions would be exactly on the lines of how it will be asked in CUET. And your aim should be to score more than 80% in tomorrow's paper. Okay, beta. So take today's day, go ahead, do revision of maths thoroughly. And kal ke paper mein, I want all of you to go ahead and perform well. Okay. So now let us go ahead and let us start with difference equation first. Dekho, what all can be asked from difference equation? Let us try to understand that. So in case of difference equation, just like differential equation, सबसे पहले तो वो आपसे order of difference equation पूछ सकते हैं, right? So they can go ahead and ask you कि what is the order of difference equation. अब difference equation होती क्या है? What is difference equation? Whenever okay. So timing is I will make it live from morning only. I will make it live from 8 a.m. Tomorrow morning. Up to you when you want to give after that. I've already given the test to the team, so it shall be uploaded today itself, maybe. So up to you. Okay. Okay. So the order of difference equation, beta, that is what is important. The difference equation is basically when we talk about the change in the discrete variable. तो अगर तो मैं ऐसे बोल रही हूँ differential में I am asking how my variable changes as time changes, but I am considering my variable to be a continuous variable. But if I don't consider my variable to be a continuous variable और मैं अपने variable को एक discrete variable मानती हूँ, so I am saying that okay, this year's value is last year's value plus sometimes last to last year's value and so on. Like we do in Phillips curve. यही तो कर रहे हैं हम Phillips curve में. We go ahead and we ask ourselves कि okay, you are given inflation of this year will be equal to some expected inflation minus alpha ut minus un. And if I just tell you that expected inflation is last year's inflation, so automatically this has been converted to a differential equation, right? Difference equation. So in case of difference equation, क्या कर रहे हैं हम? We have variable which is in the discrete format and हम उसको time period से link कर रहे हैं that this year's value depends on the last year's value. So the first thing important that can be asked in paper from difference equation is the order of the difference equation. सबसे पहले तो ये पूछ सकते हैं. The second thing that can be asked in case of difference equation is the stability conditions of the difference equation. Stability condition में they can ask you the following. First of all, they can ask you what is a stable solution. Stable equilibrium निकालना दे देंगे. I will show you an example of that. Secondly, what they can go ahead and they can do is they can ask you condition for stable equilibrium. ये पूछ सकते हैं. And at last, what they can go ahead and they can do is they can go ahead and ask you the graphical representation for different stable equilibriums. Right, beta? तो ये तीनों ही चीजें they are important from the point of view of difference equation. ये पूरा चीज is only that can be asked from difference equation. अच्छा, when I talk about the equilibrium equation of difference equation, यहाँ पे भी दो cases हो सकते हैं. They can give you a case of homogeneous or they can give you a case of non-homogeneous difference equation. Right? So overall, this is what can be asked. ये सब कुछ difference equation से आ सकता है. This is very doable, बहुत इजी पार्ट है एंड देयरफॉर आई एम एक्सपेक्टिंग कि क्वेश्चन इनमें से आने का चांस है. देयर इज अ गुड चांस दैट अ क्वेश्चन विल बी आस्क्ड. Let me start with the first case, beta. So let me just start by explaining you what is a difference equation. So जब हम time period t की value को we write it as a function of last time period's value. कुछ भी हो सकता है. Yt can be anything. It can be output as a function of last year's output. It can be जैसे हम लोग supply functions लिखते हैं. That this year's supply is a function of the price last year. क्योंकि जब मैं अपना प्रोडक्शन स्टार्ट करूंगी आई डोंट नो व्हाट विल बी द प्राइस दिस ईयर. मुझे प्रोडक्शन पहले ही शुरू करनी है, राइट? सो व्हेन आई विल बी प्रोड्यूसिंग समथिंग इट विल बी ऑन द बेसिस ऑफ द प्राइस इन द मार्केट इन लास्ट ईयर पीरियड. तो अगेन दिस इज अ डिफरेंस इक्वेशन. सो ऑल दीज केसेस वेयर दिस ईयर्स वैल्यू, आज की वैल्यू पिछले साल के वेरिएबल पे डिपेंडेंट है, दैट बिकम्स अ डिफरेंस इक्वेशन. Now, as long as we are writing this difference equation in the linear format, मतलब हम कहीं पे भी square नहीं लगा रहे, log नहीं लगा रहे, then it becomes a linear difference equation. And for us, we just need to work with linear difference equation. So this is a typical format of a linear difference equation where we are going ahead and saying कि okay, this year's value is dependent on last year's value plus last to last year's value and so on. इन दिस केस जो भी हमारे ये एज हैं, A1, A2, A3 एंड सो ऑन, ऑल दीज एज बेटा दे आर कॉल्ड एज कांस्टेंट. इन सबको हम कांस्टेंट बोल देते हैं. एंड जो भी ये हमारे वाइज हैं, दीज आर बेसिकली माय वेरिएबल्स एंड T रिप्रेजेंट्स द टाइम पीरियड. ओके, अब यहाँ पे देखो वी आर सीइंग ऑर्डर ऑफ डिफरेंस इक्वेशन. तो ऑर्डर ऑफ डिफरेंस इक्वेशन इज नथिंग बट द नंबर ऑफ टाइम पीरियड लैग्स. Number of time period lags. जैसे for example, if I go ahead and say कि yt is equal to a1 plus b1 yt minus 1, तो मैं सिर्फ एक टाइम पीरियड लैग पे जा रही हूँ. I'm just going 1 year back. So if I just go 1 year back, I'm only going till yt minus 1. Then the order of this difference equation will be 1. इसका order 1 हो जाएगा. But in this case, look into the second example. Here I am going back till 2 periods, right? I am going ahead and saying that this year's value is equal to a1 yt minus 1 plus a2 yt minus 2. So I am saying कि ये वाला जो value है वो last 2 lakhs पे dependent है. Then the order of the difference equation will be 2 and so on and so forth. So when we were doing differential equation, जब हमने कल differential किया था, there we were saying that this represents the order कि कितनी बारी we are differentiating the function, right? So this just means beta that d of dt dy by dt. So हमने एक बारी variable का with respect to time change निकाला and then we again found out its change with respect to time. So we were finding the order of the differential equation by looking कि कितनी बारी हम उसको differentiate कर रहे हैं, how many times we are differentiating that function. But as against that, here we will go ahead and we will see how many lags we are going behind. कितने lags तक हम पीछे जा रहे हैं. Now the next thing we have that is called as homogeneous difference equation versus non-homogeneous difference equation. If there is no constant involved, मतलब मेरा जो difference equation है वो कुछ ऐसा है, yt is equal to a yt minus 1. कोई भी constant नहीं है, there is no constant involved in this equation, then this will be called as homogeneous difference equation. Simple. So let's read it out. When there is no constant present in the difference equation, then it is called as homogeneous difference equation. But if a constant is present, अगर हमारी difference equation में कोई भी constant present है, like here, this is the constant present, then it is called as non-homogeneous difference equation. So homogeneous difference equation में there is no constant present. Non-homogeneous difference equation में there is presence of constant. Presence of constant. Right? Ab, depending on whether I have homogeneous difference equation या non-homogeneous difference equation, my solution will vary. तो अगर होमोजेनस होगी तो अलग तरीके से सॉल्व करेंगे, अगर नॉन होमोजेनस होगी तो अलग तरीके से सॉल्व करेंगे. Ideally, you should be aware about the proof of homogeneous versus non-homogeneous difference equation. All those proofs कि हम कैसे solution तक पहुंचते हैं, they are already there in our lecture videos of maths. But if you don't have time, अभी के लिए हमें सिर्फ उसको final answer को याद करना is also fine, because in exam we will be only using the final answer. ठीक है, that's the first thing. Secondly, sometime जैसे कल हमने किया था बच्चे, so we were given a differential equation dy by dx is equal to y by x, ऐसा कुछ differential equation दिया होता है, but you are also given that y of 0 is equal to 1. You are given some initial condition. तो if you go ahead and you plug in that initial condition, अगर आप उस initial condition को solve करके plug करोगे, what you will be getting is called a particular solution. And if you will be not plugging that, अगर आप generally निकाल रहे हो कि ये तो given ही नहीं है, and you just go ahead and get the answer that y is some function of x plus c, बस ऐसे में छोड़ रहे हो, then it becomes a general solution, right? Same is the case with difference equation. So if you are given initial condition, अगर आपको initial condition given है, then you will be getting a particular solution. And if you are not given an initial condition, oh, sorry, just cancel this out, then it will be a general solution. So initial condition given, particular solution, initial condition not given, general solution. अब आगे देखते हैं. So now we want to talk about the solution of a homogeneous difference equation. देखो बेटा, this is an example. इसको मैं general case में लिख सकती हूँ that yt is equal to a yt minus 1. ठीक है, and you are given the initial value is 8. आपको initial value already given है कि ये 8 है. अब एक बार जरा थोड़ा सा solve करके देखो, अगर मैं यहाँ पे values plug in करना start करूँ, if I start plugging in the values, तो मुझे क्या मिलेगा? If I put y1, तो ये हो जाएगा y1 is equal to 5 y naught. If I put t as 2, तो मुझे मिलेगा y2 is equal to 5 y1. If I put t as 3, तो मुझे मिल जाएगा y3 is equal to 5 y2. That is the relation given, that yt is equal to 5 yt minus 1. यही तो relation given है हमें. So if I just continue doing this again and again and again, I will be able to reach the same condition that yt is equal to 5 yt minus 1. ये एक general condition हमें achieve हो गई. Now, just try to see what happens if I go ahead and I somehow substitute. जैसे अगर मुझे पता है यहाँ पे y2 की जगह पे I can write 5y1. So this will mean that y3 is equal to 5. y2 की जगह पे if I just plug this value, I will get 5y1. So I will get 5 square y1. And y1 is nothing but 5 y naught. तो यहाँ पर मुझे मिल जाएगा 5 square into 5 y naught. मतलब I will get y to the 5 to the power 3 y naught. तो I have been able to derive this relationship. मेरे पास एक relation आ गया कि y3 is nothing but 5 to the power 3 y naught. Similarly, अगर मैं y2 को derive करने की कोशिश करूं, I will get y2 is equal to 5 and y1 क्या था? 5 y naught. So it is 5 y naught. So I will get y2 is equal to 5 square y naught. So can I see the general pattern here? I can ना. What is my general pattern? That if I need to find out y3, तो ये 5 to the power 3 y naught हो रहा है. If I need to find y2, ये 5 to the power 2 y naught हो रहा है. So if I need to find yt, this will be a to the power t y naught. This will be the general solution to your equation. बस आपको ये general solution याद रखना है. You need to remember this general solution. So let me give you an example of the kind of question that can be asked in exam. Take an example. So I am giving you that the equation is yt is equal to 7, let's say 2. Let me give you an easy number, 2 yt minus 1, and you are given that initial value of y in period 0, that is 7. The solution to this difference equation will be, right beta, I'm giving you options, you tell me what is the answer. First, yt is equal to 2 to the power 5 y naught. Second, yt is equal to 2 to the power 7 into 7. Third, yt is equal to 2 to the power t into 7. And fourth, yt is equal to 7 to the power t into 2. What do you think will be the solution to this? C. Okay. C. Good. Good. C. Good. So that means everyone is clear with the solution. तो एक homogeneous difference equation का जो solution है, that solution is of the form a to the power t into y naught is equal to yt, और जहां पे हम clearly बोल सकते हैं that this is nothing but this is this coefficient. अच्छा, one thing. Suppose they go ahead and they give you something on the time period also. जैसे they say कि हमें yt नहीं निकालना. They ask you a time period in particular, that the value of y to the power y in time period 4 will be. They give you some value, मतलब उन्होंने बोल दिया कि y to the y in time period 4 उसका value क्या होगा. So then you can just go ahead and plug it in this also clearly, isn't it? I know that the general solution is of this format, तो मैं यहाँ से plug in भी तो कर सकती हूँ. I can just go ahead and say कि okay, y4 will be 2 to the power 4 into 7 and just solve this, right? So 2 into 2, 4 into 4, 16 into 7, and you will get the answer. So try to see that not always they will be asking for a general solution. Sometimes they will ask you for a particular solution. मतलब वो आपको initial condition दे देंगे, एक time period दे देंगे, and they will ask you to solve that homogeneous system of equation. अब second point ये आता है, what if I have a non-homogeneous